Okay, so in most of the current assignments, the inferential statistics review, the inferential statistics applications, and then the final practice, I group the problems together usually with a little header that says this is the type of thing we're exploring in this group. And in the review, there was a section that says use the T, and that means the T distribution. And in this case, that's for to get the right margin of error formula. And I just want to go over the difference between a normal and a T based on problem number 8. And I'm going to use a different set of numbers than I have here based on a question that was messaged to me earlier yesterday. So, so the point here is a T distribution versus a normal distribution. When do we use one or the other? So both the T and the normal are symmetric bell-shaped distributions, but the T tends to be a little wider than normal. And that's partially to, partially it accommodates the lack of information. So we use a T distribution for a couple of reasons. If we don't know the population standard deviation, we should use a T. And or if it's a small sample size. And the central limit theorem says to apply a normal distribution to inferential statistics like hypothesis tests and confidence intervals, then the sample size should be greater than 30. So a couple of instances where we use a normal distribution are if we do know the population standard deviation. So if it's clearly given as some bit of knowledge, we would use the normal, and we would also want the sample size to be greater than 30, is what the central limit theorem states. And other times we would use a normal distribution is for a proportion. So the central limit theorem mainly talks about means. So standard deviation generally goes with a mean. So talking about a mean here, but we could have a proportion. So if it's a proportion, we're also going to use the normal distribution. And then over here, for the T distribution, again, we're talking about means, could be a confidence interval or a hypothesis test, but we don't know the standard deviation and or we have a small sample size, which means that the sample size is less than 30. Then we would use a T. We'll never use a T distribution for a proportion. Okay, so that we have kind of like 3 categories when we choose a distribution for a confidence interval or a hypothesis test. If we're talking about means and we don't know the population standard deviation and or we have a small sample size, we use the T distribution. If we know the population standard deviation and we're looking for something about a mean and the sample size is greater than 30, then we'll use a normal. Or if it's a proportion, we'll use a normal distribution. And I had made kind of a flow chart before and I posted it that kind of relates the same information just in a slightly different picture. So now let's take a look at the problem that I was asked about, number 8, and show the desktop again. So in this review section, problem 6 through 9, at the top it said, hey, use the T distribution. So to find the margin of error, you got to use a T-score, the sample standard deviation, and the square root of the sample size. So there's a couple of things I could do with that data once I have it. So now I'm going to go over to a different version of this problem. And I had several students actually have a hard time with this one because Because what I would like to do with this data is I'd like to highlight it and put it in that bootstrap interval that we played with before. So if I copy that and I jump over to a new tab, and let's go to stat key. When we first started doing confidence intervals, we played over here. Now this problem specifically said use T above, but that was way above, and so sometimes we forgot about it. So I should be going here, but what happens if I try to do this instead, the confidence interval for a mean? And that was where we went in and threw our data in. I don't have a header column or header row at the top, so uncheck that. And so here's my sample. Mean is 44.664. Standard deviation of the sample is 16.211. We'll have to modify that in a minute, but in StatKey, I could just say, hey, generate thousands of similar samples. So I've got 7,000. This question asks for a 98% confidence interval, so 0.98. And so this says the confidence interval should be like 34-ish up to 55-ish. Unfortunately, that won't answer this question properly because we were asked to use a t-distribution for two reasons. The population standard deviation is not known, and it's a small sample size. So what I did is I just kind of thought about the problem, just the way we've done things historically from a few weeks back. At first, I'm ignoring what was said above this group of things, which says, hey, use the t-distribution. So this is just a similar example. Let me blow it up a little more. Oop, no, hang on. There we go. This is a similar confidence interval I did by bootstrapping it earlier. And again, this one is 33 to 55-ish. The problem here, though, is this is a normal distribution. So sampling distributions tend to be more normal. And so this one is relatively normal. It gives me a smaller confidence interval than this problem was looking for. So to do a t-distribution here, I would need to know a few things. What's the mean of that set of data, the original 11 numbers? What's the standard deviation of that original set? Oops, over here, original set of 11 numbers. And then I have to apply the central limit theorem, there we go, which says you got to modify the standard deviation by dividing by the square root of n. So I take the sample standard deviation, which can be calculated in StatKey or in a spreadsheet, divide by the square root of 11. So I get 0.48878. Now here I use the theoretical normal, so I'm still doing the problem wrong. Notice it's about 33 to 56 this time, which is close to what the bootstrap one was. But I'm still approaching it incorrectly because I'm using a normal instead of a t. So finally I say, okay, I better use a t now. To use a t-distribution, you can't get the lower and upper bounds directly. You first have to find the t-score. And we did this in a spreadsheet in the last few days in the recordings. But here I'm doing it in StatKey. So I went to the StatKey theoretical distribution t. I'll show you that in a sec. And I plugged in my 98% confidence level, and StatKey says, oh, the right t-score to use here would be 2.764. Then according to the central limit theorem and that margin of error formula that was given at the beginning of the problem, to get the margin of error, I take the appropriate t-score from the confidence level, multiply by the sample standard deviation, and then divide by the square root of the sample size. So once I put all that together from my t-dist, I get a margin of error of about 13.5. So then we have to take that away from the mean, and then we have to add that to the mean. So notice now I get a much wider interval than before. So this one is 34 to 58 instead of the other intervals I was getting, which were like 33 to 55, 56. And a t-distribution is always going to be a little bit wider. Okay. So if you accidentally approach this problem or a similar problem by applying the normal technique, then you'll get a narrower interval than what is expected in the system, because I programmed the system to use a t, which will always be wider. It'll have the same center. It's still 44.664, but a wider center. So, and then just at the end here, I compare a t-score here. The t-score for 98% in the middle is 2.764. The z-score for a normal distribution for 98% in the middle is 2.327. Notice how much smaller the z-score is than the t. And for the same middle percent, the t-score is always going to be bigger than the normal. So how did I get that? Let's switch tabs here. Come on. Sorry, my Zoom menu is in the way. So to get the t-score, I did it in StatKey. Yeah, degrees of freedom are, it's always one less than the sample size. So I go down to theoretical t. I had a sample size of 11, so I would say degrees of freedom is 10. It's always one smaller. And then to get the t-score, you just put in your confidence level in the middle here. So that would be the 0.98 for the problem I got. And there's that t-score of 2.764. And the other side is always going to be the opposite of that. We just want the positive version for that. And I can do this in a spreadsheet also. So let's bring that up too, just for fun. Get my drive. And spreadsheet I've been playing with this week. Looks like I didn't do this one yet. What's there? Mean dogs. All right, here's one I can use. So this is review number 8. And I'm supposed to use a t distribution for this one. And I was given temperatures. And you could also use one of the pre-built spreadsheets that I put up back. Let's see. And hopefully you have these stored on your computer or in your Google Drive so you can get to them quicker. So let's see, I should have one of them here. Confidence interval for a mean. So that would be this sheet here. So you could use the pre-built. And the first tab is t interval. So make sure you pick the right tab. Are you doing a t or are you doing a z? In this case, we'd be doing a t. And then I could enter my sample data here, and then the computer will calculate the numbers I need here, and I would have to enter my confidence level there. But I just want to, all I want to do right now is just double check that t-score. So to get the t-score for a confidence level of 98%, we need to know what alpha over 2 is, right? The tail probability, alpha 2, so it's a little more work in a spreadsheet. So to get that, first I have to go 1 minus the confidence level to get alpha, and then I can cut that in half, and the parentheses are important. So that puts 1% in the tail, which is right. And so then the t-score that goes with that comes from using the t inverse. So t.inv, yep. And then tail probability, and then degrees of freedom 10. And it's going to give me the -1, negative 2.764-ish. I just ignore the negative or go in there and get rid of it by making it a double negative. So that was the t-score that StatKey gave me also. Okay, so just to try and help and clarify when you should choose a t versus choosing a normal distribution. And sometimes I just tell you in the problem, and other times you gotta it's up to you to figure it out. And again, the way you figure that out is what's the given information? Do you know the population standard deviation or not? Is the sample size small or not? Is there a proportion or not? So those are what help us decide on a normal versus a t.